Hello, School Dude Clem here, as some of you think I say. Well, I'm happy to report that I have fixed the oscilloscope. So, let's take a little look. And here it is, all fixed. We don't have that problem with the line developing spikes as it gets towards the top or the bottom of the screen. As you can see, it's absolutely perfectly consistent and flat. Channel B works just as good. Plus we don't have that problem with the dot growing into a line when it gets towards the edge of the screen. Let's just turn that down a little bit so it's not overexposed on the camera. As you might be able to see, it stays a dot no matter where I put it on the screen. Same goes for the vertical. Okay, I can see a little bit thing there, but that's a reflection. That's nothing to do with the actual scope itself. All those other weird glitches and artifacts are all gone now, and that was all because of one bad 47 microfarad capacitor. Anyway, what we got here is my ZVS circuit connected up to a coil of wire, and I've got the gate of one of the MOSFETs connected to the oscilloscope's input. So let's turn the circuit on and let's see what we have. Oh, it would help if I had that onto the DC setting. You can see some oscillation there. Now I'm going to put a can of drink into the coil and let's see if this works as an induction heater. I can see the frequency is rising. Now I don't expect this to instantly burst into flames or go up in smoke like I've seen in some videos. I don't even know if it's going to work at all. The coil's pretty warm. Well, it's getting warm. See if the can is hot. Oh, ow, yes. Yeah. Well, that definitely worked. Anyway, let's see if we can find out what the frequency is. Now this is without anything in the coil. So I'm going to turn the power on. Okay, and I'm going to adjust this so the peak, start of the peak is right at the beginning of the screen now. And, that's pretty much dead on. 1, 2, 3, 4 divisions. I've got this on, excuse me for getting in the way, I've got this on 5 microseconds per division. So let's just crunch the numbers here. Turn that off. Alright, so the length of the waveform takes up exactly 4 divisions. And we have it on 5 microsecond time base, so that's 4 times 5. So the wavelength is 20 microseconds. Okay, now let's take 1 second, which is 1,000,000 microseconds. Divide that by the 20 microseconds we found earlier, and we have 50 kilohertz, or 50,000 hertz. Now, let's take a look inside at the little fix that I did. Okay, this is the underside taken off, and you can see the things that I've done to it. I've replaced 3 capacitors. There's one here, and one here. Let's just get a closer look at that. Now I know this may not be the best repair job in the world, but it works. And there is a damn good reason why I've done it this way. You see, the original capacitors were on a part of the board that gets very hot, so, you know, that would seriously reduce their lifespan. So what I've done is I decided to put them here where it'd be much cooler, so they'd last longer. The first 2 capacitors I replaced are 2 1000 microfarad capacitors, which you can see here and here. And I learnt a very good lesson here. Double check and even triple check the polarity of capacitors, because I accidentally put one of those in the wrong way around and this happened. This is one of the replacement capacitors, and as you can see, it popped. Fortunately it didn't do any damage when it exploded. And down here is the replacement for that 47 capacitor. Now, replacing the 2,000 microfarad capacitors didn't make any difference, so they probably don't even need to be replaced, but I'm going to keep them replaced anyway. This 47 microfarad capacitor I didn't have a replacement for, so I used 100 microfarad instead because it's one of the main filter caps on the power supply. So you can go a little bit higher with those. This is a 100 microfarad rated for 200 volts. The original was a 47 rated for 200 volts. But it seems to work. Now let's have a look at some of their fault diagnosis video. By the way, this was shot earlier. Okay, here we have the scope with the top taken off, and inside it looks pretty much like what I'd expect to find. Got a couple of circuit boards here. I think this one is for the high voltage. This one is the main board, I think. You can tell this uses a linear power supply because of the big transformer here. And it looks like this area of the board gets pretty hot because I can see quite a bit of discoloration there. Doesn't show up on the camera very well, but the board around this area is a little bit darker than the rest of the board. So I wouldn't be surprised if all three of these capacitors here are dead by now because of the heat. So I'm going to try replacing those and see if that improves anything. It's going to be a little bit difficult to get them out because there's all this hot glue around them. I guess that's to make sure they're held in place. But try replacing those three and see if anything happens. And the rest is just history, because you know how that turned out. Got a fully working oscilloscope now. Anyway, that's just about it for this video, so see you next time. Hopefully I might have some of that thing built. Maybe not. Still got to plan out how I'm going to do that, because this is, as you probably know, it's a very small room. But anyway, this is going to take my electronics experimenting to a whole new level. So you can expect to see some new videos coming up from me, doing some more electronic experiments, and well, that's just about it for this video. So until next time, goodbye.